Okay, a little presentation of myself and Paolo. I start. I'm Luca. I apologize for the face. I have a technical background, and in the last 20 years I was focused on professional software development and digital product delivery. Those are some of the companies I work with. During this time, my interest shifted from inside the team, slowly moving outside the team and then expanding to the organization. And during this journey, I noticed that the technical professionals that I like more were able to connect their work, their task at hand, the line of code they were writing with the business goal of their organization. And so this is what inspired me to look also outside the technology and look at the rest of the business.
Hi, I'm Paolo. I'd like to apologize for Luca's face. You can see that coming. I have a technical background. Yes, like Luca, I have about 20 years of experience, mainly in automotive racing, Formula 1, and some pharmaceutical and some other industries as well. And I've always kept my focus on the technical side of things, not necessarily like programming all the time, but also like managing a group of programs, their teams in general, across different time zones. And Luca and I actually have worked together at Ferrari for a couple of years. We've actually, our friend Gigi over there, and we still has nightmares. So we're going to talk about some of our combined experience, and not only success stories, but also a lot of failures.
Thank you. Well, the success stories come indeed from Formula 1, not because everything was perfect there, just because it's easier to tell those stories and the success was more evident. So, during my initial years, my focus was all about the technology when I started to work. It was about learning new technologies and making sure things work the way that I need them to work. And I was learning how to become a professional software developer, right? And I was trying to find answers to questions like these. What is technical excellence and craftsmanship about, and what's the relationship between technology and these strange business people over there? At some point in my career, I indeed got in touch with some of those strange business people over there, and time to time they asked me to do some estimate, even if it wasn't really clear what type of problem we were trying to solve or what the client was looking for. And I was scared to death that they could come back to me later and make me accountable of those estimates, or guesstimates, as I will say. But on the other side, those strange business people was asking me extremely simple questions, and I was answering with very complicated explanation that no one could ever understand. So poor guys. My focus at that time was again about technology, and the relationship with the business, I would say it was almost adversarial. I mean, we had different agenda, different goal, different bosses, different trade-offs. So the best answer that I could find at that time for my questions was this. You look at the books and you look at the best or suggested practices, the principle that you want to follow, and you think, well, we are enabling those guys. Then at some point we realized that actually things were quite different to what I thought. In the moment that I thought that I knew everything, I learned that actually it was wrong. and things were really different. And this talk is about finding what is the answer nowadays, the answer to those questions nowadays. This talk is about helping business and technology to understand that what they do affect each other, and then that they need to make a decision together in order to affect each other in a positive way.
Yeah, but something is in a lot of teams, of course you have, actually a lot of companies in fact, you have the business side and the tech side, they're really separated. They don't talk the same language, don't speak the same language, and they don't, not always they have a shared view. So sometimes the developers feel like, they feel a bit frustrated because the business wants something that they don't think is good for some reason. At the same time, the business don't, sometimes developers want just great things, like installing the latest JavaScript framework, or using the latest technology, and they don't care about all the security risk and all the other policies that are in place for some other very important reason. And there's always a bit of friction. And I think because we've worked on both sides, in fact, Lucas worked more on the business side of things, and I was more on the tech side of things. We've seen these things. And we know that this. What I'm saying is that this small talk is going to be about communication between the teams, as in business and developers, and also within developers and in the business.
So let's see if we have someone from the business and product side of things here, or do we only have technicians? You're from the product side?
Marketing, yeah, kind of.
Marketing. Anyone else from product or?
I don't have a case in mind.
Okay, but you are from business and product. Anyone else from business or
I
product?
was a product owner, not now, but
You were. And any of you can come up with some case when you had a business opportunity that was lost because of any case that you want to mention?
Yes, and I mean, we have the technical resources, but sometimes it's like we're working on so many other things that we can't put any other technical resources on it, so we may lose the opportunity because we can't put technical resources on it.
Yeah, understood. And any other?
Yeah, I'm from the IT side, and I can sort of explain the way that work gets allocated and prioritised. We're very good at asking people to come up with ideas and pitching and approving them, but then the availability to execute those ideas is always overwhelmed with the amount of ideas which are waiting to be executed. So after about 6 months, we go through and we cull a lot of these things, which is a real shame.
Yes.
And the other side of things is that business decisions that have a negative impact on technology. I guess since the majority seems to come from technology, there may be many of these. But anyone that you want to shut up?
If you need another drink before...
Maybe two.
I think, not necessarily a business decision, but a change of decision, a regular change of decision,
Yes.
has caused delay.
Yeah? Yeah, I think that. Any more? So, as I mentioned, we will go through 4 real-life situations, and for each of one we'll present at least one epic fail story and a great success story. So let's start with the first one. So we're talking about a situation where a company had a discrete success with their product, and the next step is to sell that product in new markets, new countries, and to scale the number of users. And our first story is about a fintech startup and a bank company. So when banks go to different countries, it means that, or a fintech company, they have to deal with different regulations potentially. different ecosystems. Every country has different payment systems. There are some, like PayPal, maybe you find it everywhere, but then there are local payment providers that you need to implement. And slightly different users' needs, habits, and desire. So when this happens, business go to IT and say, you know, we need to do these things in order to release this product in this new market. And what happened is that in those two cases, business could not respond quickly to those needs because the code base and the infrastructure was in a not very good state. And that was because in the first place, tech didn't have the time to do things right. The solution was taking more shortcuts and cutting more corners. So specifically in this story, the fintech approached the problem like this in order to respond quickly. They almost duplicated the code base for every new country, almost the old code base. The bank took a different approach. Can you guess which one? Go.
Hire 30 contractors.
No, that's right, that will be a classic. The other classic, I tell you what is the other classic is adding a conditional statement if country is everywhere in the code base. So this lead to code base duplication, conditional statement, and you know what it means. Maintenance cost ballooning up. Then you have IT operation cost per users surging, exactly the same things. Head count in the IT department hitting the ceiling, because then when you do like this, in the end you need to hire more people to do the maintenance when you have this code-based duplication, right? And then you start to move from a technical debt slowly into a technical bankruptcy. And that's what happened for those two companies. To be honest, we have also seen a different approach. This is when IT kind of win the fight with the business. It can happen in small startup led by technology, or it can also happen when the code base is reaching the end of life stage. So there is nothing you can do. The code base is already in such a terrible situation that you cannot pull a rabbit out of the hat. So the business in this case is asked to wait and to slow down. Come on. This was the business slow down until it falls. All the business opportunities are lost. The client goes somewhere else, and this is how it ends. Well, the Formula One story is a little different. Let me tell you what is the problem in Formula One, what it means expanding a new market and scaling to new users. So, Formula One, race engineers usually know how to code. They know how to code, and we give them access through library. We give them access to real-time telemetry, historical data, car setups, and so on. So when they have a specific need, an ad hoc need, they can code something, maybe with Excel. They can connect to our libraries and use macros and VBA, or with MATLAB or Simulink.
Maybe I can add something to this. So yeah, the engineers are also in a way programmers. Not all of them are very good programmers, but they work good with MATLAB, for example, or with Excel. The thing is, what they do is sometimes because they work a lot with simulations, right? So they simulate like time model, time degradation, or even the winds for the car and the airflow and everything. There's so very many different simulations, and what they try to do, they come up with a new, slightly different mathematical model to try and enhance the car, and they test the model against the historical data, like telemetry from previous races, for example. Then they use these simulations to also predict how the car is going to go in the next race, so how to make it go faster. Right? And the issue with that is that these cars are prototypes. which is why you don't find them in shops. There's just one of a kind. They'll be quite expensive as well. So but that's a different reason. So what they do is they can program some Excel or MATLAB or Python, whatever. And then at some point they reach the point where they have maybe a good simulation that they want to try. But what do you do? Do you roll it out to every single user at the track during the race? And then if something goes wrong, what do you do? I mean, how do you deal with this? And because the race is like 2 hours and that's it. And yes, you have some time during the weekend for free practice or qualifications and stuff, but it's still just a weekend. So, and there's also people at the factory that are working on maybe 2 races ahead, or even sometimes working on the car that's going to be built the following year. So how do you deal with this, with all these deadlines every week or every couple of weeks? Well, you have to put yourself in a situation where you can easily roll out features and roll it then back. So what we did, and it didn't take a couple of days, it was a very, very long process, we sort of transformed our main app into a sort of a small operating system, and we started to consider every feature of this app as it was a little, every feature of this app as a little independent app. So the main app is now a little operating system. All the features are like little apps, and we had a system in place that would allow to plug one app in and out, change version, and maybe just open one version to a particular subset of users. Maybe some users at the track will be allowed to use both the current version and sort of a prototype, or maybe people at the factory could have models. But in order to do this, it's not something you can easily add on a software if the structure of this software is monolithic. And when you start working in a company like Formula One company or any big company, it's not greenfield. You're not going to go there and there's nothing and you start your hello world thing and then you expand from that. So there's thousands and thousands of lines of code, and there's the IT and servers and technology. The technology stack is, it's pretty crowded, let's say. So how do you deal with that? And the way that we came up with is that if it was to divide this application as much as we could, but it took time and a lot of tests that we had to retrofit in the application. We also taught engineers to write tests on their model, so that it would be easier for them to realize whether the problem lied in the application itself or in the mathematical model they used. Because otherwise, you just get a call saying it doesn't work, and it's like, okay, what now? So to also respond to that, we had to divide the application in very many different parts. But this was a long process.
Yeah, you mentioned some of the things that we did in terms of design.
Yes.
In terms of design, you mentioned the support. So the application need to support multi-users before it's an ad hoc application. Need to support multiple sites: the race side, the test side, the on-factory run at the same time. Need remote access and replication, security, backup and restore, versioning, and automatic one-click remediation plan that you were mentioning. If something goes wrong, we need to quickly go back. And two things that we did, the two high-level concept, is actually relentlessly pursuing simplicity. It means avoiding unnecessary complexity and over-engineering. Like Paolo was saying before, not to throw in new framework and new technology just because it is cool. It means instead following the KISS principle, Yagni principle, avoid premature optimization, and look for simple design with low cost and high flexibility. It means having conversation with the business, understand where business and IT hold the lower ground. It means where there are more unknowns, where there can be possible changes, where changes can possibly come from, and which one of those changes can have the highest cost. And in those places, introduce some degree of flexibility using the design, only where required. using a principle that you were mentioning before, low-cost design, modularity, separation of concern, low coupling, open-closed principle, and so on. But avoiding overdoing it, so avoiding speculative generalization or a configuration obsession for the technical people. Let's make it comfortable just in case, because we don't know. And all that type of expensive flexibility that we will never be useful for the business in the future, but now it's wasting our time.
And also, we should mention that, of course, everything comes with a cost, including tests. So even if, you know, with Agile development and stuff, you know, everybody says, oh, you have to test everything. Well, do you? Because tests are a cost, and sometimes you need to build something that just works for one day and then you throw it away. And it could be even a spike. Even the cars are prototypes, and there are some things that you just want to try once and then just get rid of it. So it might be not the best idea to pick up your extreme programming book and just read it first, and then write a few classes with two classes with two tests, and that's it, because you're going to throw it away. You need to be pragmatic. It's not everything, but you don't need to follow a book as it was some sort of a religion,
Bible.
something like that. The other thing I wanted to mention is that, yes, simplicity is the key, but to achieve simplicity, it takes a lot of discipline, because it's very easy to say, oh, we should do this modularity, we should use modularity, or this should be done in an incremental way. But the definition of incremental, I've realized, is not really shared. I mean, everything is incremental if you think that time just goes by, right? So just everything is increment of time. But the trick is, while you don't want to just let the time go by and have the entropy of your system growing, okay? What you need to do is, after almost every change, you need to go back and simplify your system immediately. And sometimes you even have to simplify the system before you add a new feature, because otherwise you just end up, adding layers and layers of technology, and the application becomes unmaintainable. And there's one thing that both the tech people and the business people immediately understand is the cost of a change. And generally, developers only think of cost of a change in terms of time. They go like, oh, it's going to take a week to do this. Whereas business does not even compare by time. It's time and money. So if you keep your system in a very simple form, it's going to be easier to change. But this takes a long time. You need to train developers, and you need to train managers as well. But you get some resistance from developers as well.
We have a second situation, and is about having that flexibility that enables business to make a strategical decision or define a strategy instead of reacting in a very tactical way, like I think something you were mentioning before. And we start with the epic fail again. Fast-growing online research company and the same fintech company as before. So the goal is to create new product, but reusing or integrating part of the existing product. The company has been successful with one product, has expanded in new markets, and now they are so happy that they want to create more products. But can we do it faster given what we have built before? Well, you would suppose you should be able to do that, given that you have a lot of assets now, right? But reality is that the technology go back to the business, and this is the menu. There is just one item of it, and you like it or lump it. That's it. Because again, the poor status of the code base, the capability or functionality that the business would like to reuse or would like to decide, can I reuse it? Do I want to adapt it? Do I want to build it again, or do I want to buy it? Those options that is normal for the business to expect are not there because of the complexity of the technology, because everything is connected together and cannot be separated, or only trying to estimate those things is impossible, because you take, you pull one part of the system and the whole system comes with you. There is no reuse, it's all or nothing. And again, the business did not make space for technology to prepare for this type of flexibility, and technology didn't thought about that, and this limit business decision only to short-term thinking, and that is the problem. So it's something bad for the business and something bad for the technology. More examples include when a business wants to change switch from one technology to another, switch from one vendor to another. Oh, that the cloud provider is better than this one. Can we just switch so we will save a lot of money? Yes, but we don't know how much time it will take and when this will be done, or if it is even possible. Or we want to integrate with an external provider that gives us that service like that. But then estimating the effort of integrating, it's impossible, or it's really unpredictable. So even in Formula One, time to time, we had to switch to different technology or to upgrade to newer version of tools.
So one story about this is in a bit of a background. So the Formula One cars have a little onboard computer called the ECU, the engine control unit. So you may think of this little box as the one that's in charge of acquiring all the signals from the sensors, but also it runs some software that actually manages the car. So when the driver goes into the pit lane, presses a button to activate the speed limiter, and it doesn't do much. It just presses a button, and then the control unit slows down the car and makes it so that it doesn't go faster than whatever the limit is. And it's all very good. Big teams have developed a lot of tools around these ECUs, not only tools to program the ECUs, but also tools to analyze the data that is acquired by these cars. And this has always been very expensive. And then at some point, the FIA, which is makes the rules in Formula One, decided to have teams like smaller teams, like with less money, to join Formula One. Everybody would have to use a standard ECU, so that it would be you come with a set of tools, like you get a box, you get some telemetry and analysis software, some simulation software, and that's it. And there's an entry price that is more affordable. But of course, the big teams, they didn't want to lose all the tools they had written in the past 15 or 20 years. So what the big teams had to do was to build interfaces and filters and bridges, adapters, if you want, so that even if you plug this new box in the car, then everything else from the car to the garage and telemetry and everything would work as before. But it's not. Of course, it's a big constraint. Like everything depends on the data acquired by the car and the telemetry. So this small change, like a box, it's massive for big companies. And yet you have just a few tests during winter, and then in a year's time, it's going to be the first championship with a new box. So I think one thing that we sort of were forced to with working from Formula One was that we were given a pace, like a rhythm, if you want, and you had to adapt to it. So we had to question ourselves and say, look, the usual way of approaching development is not going to work with this, tight deadlines, and so we had to reinvent. Well, not reinvent itself, but we had to change the infrastructure so that it would be easy to make changes. That's the trick, really. And just as a side note, even the weight of the box is a problem, because if the box say weighs a kilo, say, then the new one is like 1.3 kilos, then you have
you have to send
car.
the driver on diet.
Exactly. You have a heavier car. If it's lighter, it's easy because you just add ballast. But if it's heavier, it is a problem. You have to move stuff around, because maybe even the size of the box is a problem, because maybe it's thicker So you have some wires that you have to move, and then it turns means you have to move some other bits and pieces. It's massive, something like that. And the only way you can deal with this and getting alive out of it is that you need to simplify your structure. You need to make sure that you can change things in a reasonable time.
And while Formula One make it clear that there is some pressure and some rhythm that you need to follow, this is true also for the other businesses. For every business it's the same. Competitors are not sleeping at night. They are fighting to get ahead of you. It's just that Formula One make it impossible to escape those deadlines. The race starts at 1 o'clock, no matter what. Are you ready? If not, good night, someone else is. So Formula One pushes us to learn those lessons, but every business faces exactly the same challenges. And you mentioned the ECU. FIA, for example, changed the type of timing used at the test site, new sensors, new framework or developer tooling, the tool chain. And what we learned, like Paolo was saying, the importance to go from high coupling to low coupling, reducing dependencies and making things composable so you can replace part of your system easily. And you were also mentioning the monolith, going from a monolith solution to a modularity where modularity matters, where, you know, as I was saying before, things could potentially change, so you want to build in some flexibility in order to be able to respond to business requests or business changes that require that level of modularity. To be honest, we also have seen modularity, people overdoing it. I don't know if you are old enough, those of you that come from technology, if you are old enough to remember the DLL hell, where people got crazy with hundreds of unnecessary DLL. Nowadays you have the microservices hell, where you have extremely small microservices, but guess what? In order to release one, you need to release other 50 microservices. So I'm not sure what to speak about that at all. Third case, third situation, moving fast, reducing time to market and costs. Here we have an online gaming and betting company. This company entered the market pretty early, so it was very successful and making a lot of money. But then other companies entered the market. So the market started to become more competitive. Users had more options and start to get used to more functionality and nicer things. So the company had to start to run faster in order to maintain the leadership position. And they start to push IT. We need to release faster, we need to release faster, go, go, go. To the point that, again, code base and infrastructure start to become a mess. Adding new features was like cleaving a human tower that was getting taller and taller, or making a move at Jenga. Again, every time getting taller and taller and more difficult and more risky. I mean, how do you feel when you release Friday? You have the feeling that you are putting the last pieces on top and hoping that everything doesn't crash down, right? That is the feeling. And that company was dealing with unsatisfied customers and clients, keep waiting for the missing feature or for the bug fix, miss a deadline, the profit, the margins reduced, because when you build a software like this, it takes a very long time. The competing products were costing less because they started later and they had the greenfield products, so their code base was much better and easier to go fast, and diminished predictability. What happened to that company is that the company lost momentum. The customers start to run to other competitors' products, and that company was sold. The IT department was thrown away, and all the customers were migrated to the new company. That's what happened to that company. Even in Formula One, we have the competitors. Our teams are our competitors, and they also have an IT department and developers that try to create more competitive advantage for the other teams. It's like a nice game. You have developers on one team and developer on the other, and they try to fight each other. But that actually happens in every business if you pay attention. Our goal was to maximize the number of features and even more the value created during the championship that have a clear start and a clear end, the end of the season. And of all the huge code base, we're a relatively small team. We had to improve simulation, things like telemetry, lab compare, engine mapping, or...
Yeah, so one thing we can say about this is that one way, might sound very simple, one way to maximize the time that developer can spend building a product is to automate everything else. Okay, because even with some, well, not even, it's very actually common that even in big companies, there's a very slow release process or even a slow build process. And in fact, I think even when we started in the early days of our early days of Formula One, there were a lot of manual steps even to build the products, and this would basically imply that some developers had to babysit like a build machine, and if something went wrong, had to do some manual testing and a lot of this. And this is time, and if for any reason something was wrong, you have to go back to the dev team and maybe make changes and stuff. So, I mean, these days a lot of people use continuous delivery software, GMC, the likes, or even continuous delivery. But I think those tools are very important these days, and not just those. Also, scripts and any other tool that you can use to avoid unnecessary manual steps. So the idea is the developer should have like a full day to develop, like rather than firefighting or babysitting systems and even building. And one other thing that we had to face was, and Luca was mentioning this, is that in some companies you have contractors like developers, different departments of the company may hire different contractors, and some of the things they work on are in fact the same. So you can imagine that that if we keep talking about Formula One, you can imagine that some simulations that you run for the tire degradation, they can be used for some other kind of degradation, right? Not necessarily tire. But maybe those are two different departments, and maybe one department has the budget to hire two contractors to start working on some degradation model. Then the other department at some point has got the budget as well, hires two different developers to work on a very similar degradation model. The whole thing is going to go into one big system. You end up with lots of different versions of something that looks very similar. And this, in turn, becomes very challenging for the honest developers that join the team, because when you look at somebody else's code base, you have a bit of experience, you're always like, I'm not sure why they did that, and this is wrong, or maybe we should change this, or maybe we shouldn't be using this database, we should be using MongoDB or whatever. But in fact, that's a mistake. One of the very important things that an experienced developer should do is to observe and absorb. You can't just go there and say, oh, this is bad, and just change everything. You need to understand how they ended up there and what they were trying to solve, because we always complain about our customers coming to us with their solution rather than with their problem, but we do the same. You start looking at the code base, you start writing some code like, oh, I did do that, I mean, that's wrong. And then at some point someone comes in saying, oh, we did that because of that. And you go, okay, so yeah, now I get it. And again, this is communication. You need to calm down, especially junior developers. Calm down. No, you're not going to install React on the car. and things like that. And
Really? Can't I do it?
and no, the driver doesn't want to drive with the iPhone like that. He still wants a steering wheel. But this communication is very important, because when there's lack of communication, then you have lone rangers, people that just spin off and start doing their own development, and which just diverges. And it's still responsibility of the team to maintain it. So yeah, it's communication and simplification and run out of objectives.
Discipline.
Discipline.
And look at what you are doing in terms of value that you are creating to the business. So comparing to the picture that we were looking at before, the Jenga towers, the feeling that you get when you approach development in a more disciplined and methodic way feels like this, gradually, steadily composing pieces of a puzzle. But even if you got it wrong, the puzzle will fall on the table. You will not have a Jenga tower crashing down or a human tower, and that's the feeling that we had at some point when we start to make some order. That feeling of releasing software in a way that feels relaxed. When you are doing it right and you are releasing, you feel it. You are not stressed, you don't have the adrenaline. It's just the release, it's a normal thing, and if something goes wrong, you click a button and you roll back to the previous version. You are always safe, nothing can go wrong. Or can always go wrong, but from firefighting to one time out of 1,000, it's a big difference.
Yeah, and one other thing it's always about communication is that you need to explain to the business what you're doing. You need to have like one team with the business, because one other problem that we've seen a lot of times, I'm sure you've seen a lot of times, is that if the business comes to you and say, oh, we need this feature or this little product or this thing, how long is it going to take? Is it going to take? And you've been there for a while, you know the domain, you know the code base, you know everything, so you're pretty sure it's going to take, I think it's going to take like, it's a guesstimate, but not less than 3-4 weeks, okay? If they pick up the phone and call the first consultancy agency that offers offshore, or even, not necessarily offshore, it offers development, they go, oh, we have this problem, what do you think? They say, oh, I think it's going to take 3 days. And we've had a lot of 3 days examples in our past where a contractor will come in and say, oh, this is easy, it's going to be 3 days, and then 3 months in, he's not even halfway through because he doesn't understand the domain. So everything he touches is going to, it's like Jenga. Or what's the other thing with the search and when you sorry?
Operation.
Yeah, operation table. And so someone comes in, he doesn't understand the domain, and just puts a spike into the code base with something that only works in a very restricted, constrained environment, but it doesn't really work with anything else. And you have to resist those things, because then we also had examples, we had a lot of examples. Anyway, we also had examples where it's like a bit of a virus. You have these, these people coming in trying to build something that will never work, but now that thing is in the code base. And then if someone else
go back to the Jenga.
Yeah, if someone else is working on a new feature, maybe spots a method or a function or even a library that's being used somewhere else, it's like, oh, maybe this comes in handy, without knowing that that was part of the virus that was trying to be injected in the code base. So that's why you need to have the business involved, everybody involved.
Reliability, the example with reliability, I think you mentioned that the same online company, betting and gaming company, first was falling behind, but soon after, before being sold out, had to start to deal with reliability problem, firefighting. So everyone is busy trying to avoid interruption of the system, because when the system is down, also the money stops to flow in, right? So everyone is busy in firefighting. The few people that is not busy in firefighting are trying to fix bugs and do support. Who is building features? So this is kind of the great idea. Let's create 2 teams. the teams that are rewarded to deliver software in production as fast as possible, doesn't matter what is the status of the code base, and the team that is rewarded to fix bugs, again, as fast as possible, doesn't matter if you are solving the root cause of the problem. And this lead, take the productivity down 10 times. I observed this because I had to do some due diligence to different companies, and one company had 40 developers, and another company in this type of setting had 400 developers to do the same type of job. 40, 50 around compared to 400. That's how this fighting can lead you to. Again, in Formula One, we have similar problem or similar need to create reliability for our customers to avoid the problems and waste of time to the race team and to recover quickly from bugs and incidents. It happened. We had Massa stranded while Massa was fighting for the championship against Hamilton. During a qualification, was stranded because of a bug related to the electronic, to the ECU, electronic control unit. And Alonso, strategy mistake caused by a user this time, and I think he was fighting with Webber, and then who won the championship that year? Not Alonso.
Not Alonso.
So bugs happen, but what we did, what worked well, instead is that we, instead of separated release and bug fix maintenance team, we had teams that were responsible from the ideation to maintenance and the commissioning of the system, responsible of the whole life cycle. That's what we did. Instead of just fixing bug, we were trying to look at the root cause, how the bug entered the system in the first place, and how can we avoid that people can make that mistake, or which system do we put in place in order to catch those mistakes, because making mistakes is human. We always make mistakes. The important is not to repeat the same mistake twice and have systems that catch those mistakes automatically. And then instead of last mile testing or Q&A, how do we start to test things since the beginnings with code reviews, or even better with pair programming?
Yes. Yeah, just one thing I wanted to add on this. Again, not going to say again simplicity and technology stack, but I just want to give you an example of what we mean by the developers need to understand what the business does and how they use the product and why they use the product. So for the F1 car, what engineers do at the track, for example, is that they analyze the real-time stream, telemetry sensors for the car, and this is not just to to tell the driver, do this or do that, but some of the sensors are very important for the safety of the driver. And what happens is you get the telemetry is displayed on some charts or whatever, and what the engineers do, they use programs to enrich this telemetry with some calculated data. It's a bit like in Excel, where you have some cells that depend on the content of other cells. And to give you a very stupid example, you get a sensor gives you the temperature of the tires, maybe on the average temperature. You're not going to get that from a sensor, so you write some formulas. And of course, formulas, especially for the aerodynamics, can be very, very complicated. Anyway, the bottom line is, maybe you write a system that can compute this formula pretty fast, let's say in less than a second, let's say in 0.6 seconds, except that the car is running at 340 kilometers per hour. So 0.6 seconds means that when the engineer is looking at the chart and is looking at where the car is on the track, the car is not actually there, it's like 150 meters away. So that's why you need to ask yourself, developers in general, the IT team need to ask what the product is used for. You need to help the users to come to the same vision of what they're building. Because otherwise, developers will just play with code and maybe come up with a beautiful algorithm that takes 5 seconds to compute, but hey, you can print the code and hang it to the wall because it's just beautiful. And this lack of communication, I know I've repeated myself, but it's key to make something like this work. Plus a few months.
I think at this point I'm going to stress that so the communication and the relation between technology and business, they can influence each other in a positive way or in a negative way. And when it's positive, you get a virtuous circle. When it's negative, you have a vicious circle. And this is what happened when it is a vicious circle, the spiral goes downward, and you go from technical debt to technical bankruptcy, and from the business side, you go from slow sales and non-competitive products into shrinking market share and losers. Instead, when things works well, it's a virtuous circle and the spiral is upward. You go from continuous improvement to technical excellence, from good product to great profit. And going back to what you were saying about the importance for business and technology to talk together, actually the way that things normally work is that someone in the business has some great ideas, they want to have some business impact, someone from the product come up with a great product vision, and then somewhere in a silos, IT try to implement a solution, and so on. But point is, like you were mentioning before, Paolo, in order to do the right things, in order to create the technical excellence that matter, business and technology need to share a common context, a common understanding. They need to look and understand the same problem. That is fundamental. So instead of working in the traditional model, they should constantly work together, communicate, be in sync, be on the same page, and work in small iterations, so they will also have additional feedback and see what is working and what is not. Because we learn a lot of things because of the fast feedback loop of Formula One, and we learned what was working and what was not, because we were working together with a race engineer, sharing the same context and using feedback loop to see what's working and what's not. The key message is that from the technical point of view, what technical excellence means can only be defined in context of the business needs. You cannot read the definition of technical excellence on the book. That's not enough, it's the starting point. The next point is to apply that in context of what is needed for your business, for your product. And at the same point, a business can set a strategy only once understand the technical constraint, but also the opportunities that can come from the technology or new technology. So also the strategy, the business cannot set work in silos by themselves. They need to work together, and the plan, the technology plan and the business plan need to be co-created by business and technology together. You cannot live alone. So very quickly some final quotes to reinforce the message. This one is just a picture from McLaren where IT started to enter in the 70s as telemetry, in the 80s inside the car, in the 90s to pervade the old Formula One team. But nowadays, driving a Formula car and driving a Tesla is like playing a video game. You don't have any physical contact with the mechanical part. You are dealing with electronics that is dealing with software, and then that is controlling the steering wheel, the brakes, and the engine. It's like if you are playing a video game. So nowadays, software is the product. It's not the enabler of the product. The software is the product, no matter the business that you are in. Here we have another quote that stresses exactly the same concept. Here we have another one.
Actually, I just want to add something on this. At some point, because we worked many years, about 10 years in racing, so we've met different managers, different software developers, good and bad, both. But to go back to what Luca is saying right now, at some point, one of the managers, this was at Ferrari, during a meeting, he said, "I now realize that the software is part of the car." And this was, of course, after months and years of working. But it's an eye-opener. Because if you change your mindset and realize that it's not service, software is not a service, it's a part of the business, part of what you're building, then your approach, both from the business side and from the development side, changes dramatically. And this is what we're trying to communicate.
So we created our own quote, so to pretend that we are important too. And Paolo, look at the quote that you just wrote.
Yes, that's us.
In real time for you. So
People studying on the phone, right?
So this is where my journey started. This is what I understand nowadays, and the picture is a little different. And to finish this presentation, a question for the technical people. So are you ready to redefine technical excellence in the context of business and not closed in your room? And the business, are you ready for nowadays digital world? And that's it.
Thank you.
I think you have some feedback forms.
Yes,
Am
yes.
I right?
So before going back to the pizza and the beer, if you want to leave some feedback, we don't have the pen. If you have, Roy, I see that you have, so I want the feedback from you. You can pass.
I actually have some markers in my bag. This will not be the best one, but it is very important. Have some sharpies here. Thank you so much. We'll love you to have you in. And more or less in a month's time, should be enough during the weekend. We'll have another one. And thank you so much for coming. Hope to see you soon.
Thank you. Thank you. Can we drink beer now?
You can go drink beer, yeah, and have pizza. And we have like 15 minutes-ish to then dash out.
Okay, now we can get wasted, Paolo.
So that was the strategy.
Thank you.
It's one of those age-old questions. How do you kind of break down those traditional barriers that thinking solve the problem?
Okay, I lied. We can still in the room until 9. Please help yourself. Have a talk. Interact.
Here, guys.